Welcome to Lecture 14 of Stanford CS193p, spring of 2025. Today is all demo. We did a lot of work on the last lecture to make all of our model be @sign models, and today we're going to use that wonderful thing that we built to use the database to search and query and do all those things. So that's what we're doing today. Here's where we left off. I haven't been doing this, but I'm going to actually go back over everything we did on Monday. Just because I tended to be going around to different files and I was changing things here and there, and we were bringing things in from ChatGPT, and maybe it got a little mixed up and crazy in your mind, like what's actually happening here. So let's just go back and look at every single change that we made on Monday, and I'm going to do it using these nice blue bars. You see these blue bars that get put on the side when you have a repository? You guys are all used to this. So let's just go through every single file here and look what we did. In code, part of our model, we changed it to be an @sign model class from being a struct. That was one of the main things we did there. And of course, we had to import SwiftData to make that happen. So that's why we have this blue. And we had to change kind to be a string because we can't put kinds in the database. It's not one of the things we're allowed to do. And string is a primitive type, so we're able to do it. And we just made that easy to do by adding this computed var, which converts it to and from a string. And we got that conversion code from ChatGPT. So that's all we did there. And then we had to add an init to code because it became a class. And the init we get for free in classes has no arguments, but we clearly need some arguments, the kinds and the pegs right there. And we also changed our missing peg to not be a color anymore because we changed our pegs in another file to be strings. And then the only other blue changes here is we took off mutating from randomized because classes, all funcs are mutating, and the same thing here with reset. So that's all we did in code. We actually didn't do that much here. It was mostly this kind thing as part of our model conversion. Now, in CodeBreaker itself, maybe one of the biggest things we did was we changed this import from SwiftUI core to Foundation and truly made our model be UI independent. It has no imports of anything about the UI, and we were able to do that because of this part of the blue change, which is I changed peg to a string. And you're used to that. You did that in your assignment too, I guess, or whatever it was. And CodeBreaker was already @sign observable, so it was already a class, so changing it to model wasn't that big a deal. But we did have to mark these relationships that we had to all of our codes so that when we deleted a game, a CodeBreaker game, it would delete those codes in that table, in the code table, because codes are @sign models too. They have their own table. And then here we made start time @sign transient because it really doesn't make sense to put the start time in the database and then come back a few days later and have it load out of the database and be ticking from that start time 3 days ago. It makes absolutely no sense. This @sign transient actually caused a bug in our code, which is that the elapsed time doesn't get started properly. And why is that happening? It's because @sign transient vars don't kick off the SwiftUI updating. When they change, the UI doesn't change. So we could actually fix this @sign transient thing really easily by every time we set start time equal to something, let's touch one of the other vars that does cause an update. It's kind of a little bit of a hack to make this work, but we don't touch start time that much. So here, I'm just going to have this start time equals now. I'm going to say elapsed time plus equals 0.0001. I'm just going to increment my elapsed time by microseconds or however much that is. And let's see where else we change start time. Here we're pausing the timer. We're setting start time to nil, but we're also changing elapsed time, so that's no problem. Here we're restarting. Again, we're setting the start time, but we're also setting elapsed time, so that's no problem. And that's it. Just that one little change here will make it so that our thing will start ticking again, so that every time we change start time, we also change elapsed time, and then the UI will update. What else do we change in blue here? All we did with this init is we just made it so it didn't have the default peg choices being mastermind. That's because they were colors. We don't want any colors in our model anymore. That's for our UI to do. And then down here in attempt guess, we had to create a code when we were making a copy of the guess to an attempt because we don't have value semantics anymore. So down here, we removed our little extension that made CodeBreakers identifiable, hashable, and quotable because @sign models are automatically that. So we didn't need that code. All right, how about in our CodeBreaker view? Well, in our CodeBreaker view, we only did this one little blue area here, which is that we added 2 convenience functions an init and a var that would essentially let the rest of our code continue to think that our model deals with colors, but do the conversion to strings. We use hex strings to represent our colors. And by adding these two things, we really didn't have to go all around our code and do much, because we've essentially put a little wrapper on our model. And this is UI code. Colors are a UI thing. Our model doesn't know anything about colors at all now. People have mentioned this idea MVVM. Have you heard that phrase? And I used to teach that in this class as a main thing. Another way to do this would be to use something like MVVM. And the VM part of MVVM would allow you to create a little observable that's in between your model and your view that would do things like this. Bend your model in more of a way the UI thinks about it. So this is lightweight MVVM, but we're not creating an actual observable VM here. We're just doing it as an extension to our model. Then, of course, we got ChatGPT to make colors into hex strings. In our game editor, we only changed this one line of code, which is that when we're doing our peg choices chooser, remember that's the thing, we create a new game or we're editing a game and we get to say what the peg choices are, and we got that color picker and all there. That whole thing is obviously editing colors, and our model now doesn't know about colors. So again, we use that little convenience var that I just showed you to bind into that. And this is to emphasize that binding into a computed var like that, perfectly fine. SwiftUI does not care when you're binding whether it's computed or not. Match markers, we just moved the match enum out of there because it was there for historical reasons. Peg choices chooser, this thing right here is the thing that has the color picker in it where we're picking it. And all we did here is we just said that it's no longer really a peg chooser, it's a color chooser. So we changed its argument to take an array of colors, and we changed its preview to pass an array of colors here. And that's it, just those two lines of code. See, those are the only blue lines. And then that thing I just showed you where we used the different binding allows us to use this. And then peg chooser, we didn't have to change at all. There's no changes here. It's just that our preview was picking some samples, which were colors. So we had to map that to be hexes there. And our peg view, we made one of the most important changes of all when we switched from colors to hex strings, is that when we're doing our foreground style of our little peg shape, we have to go get that color from its hexed string value. So here is where we're mapping the way the model thinks about things with strings onto the way the UI thinks about it with colors. And same thing in its preview down here. So that's it. It's all pretty simple, minor modifications. Any questions about anything we did there on Monday? We left off on Monday doing this, which is that we added this model container and import SwiftData to our Codebreaker app. And actually, you know what? I'm going to commit my changes here. That was lecture 13, right? Well, 13. Stage them all, commit. Now that we've done the blue, we don't need to do that anymore. So we have this model container here, and that's a really incredibly simple way to create the little container that contains the SQL database on file somewhere and knows how to map our @sign models to a SQL schema. It's actually amazing. That one line of code is probably one of the biggest lines of code in this whole thing in terms of the amount of work it's doing. But there's a little bit of a problem here, which is that this is on the game chooser in our app. What about all our previews? See, they don't run this code. The previews are little standalone view things. So we have to go fix our previews to have a container, because they're using Codebreaker. They need a container too. So how the heck are we going to do that? Well, I'm going to do this in a way that's really general and really powerful and that you can use in any app, but it's a little bit sophisticated Swift. So this is another one of, okay, you can cover your ears and I'll tell you when you can let them off, and then I'll tell you at the end how to just make it work if you don't really want to think about how this works. But let's take a look at this. Let's go to our first view here, Codebreaker view. It has a preview that uses a Codebreaker. So this clearly needs a model container or it won't work. In fact, watch, let's try and do it. Canvas, here, show me my preview. Crash, because it has no container. It can't create a Codebreaker. It's an @sign model. There's no container for it. So that's no good. Now you'd think, well, can I just fix this by saying .model container for Codebreaker.self? Just like I do in my app? This should work, right? No, this doesn't work either. Why not? Because look at this line of code up here. Okay, this line of code creates a Codebreaker, but it's not affected by this thing right here. And you can't put this out here. That's not legal. This preview thing is not a view, so we can't put a view modifier on there. So how the heck are we going to get this whole thing here to have a container to do stuff with? Well, what we're going to do is use something called the preview trait system. And it looks like this. You say traits, and you can do things like landscape left. That's a trait. And if you put that trait on here, then your preview will show you your preview in landscape left. And there's a bunch of traits in here that you can do with things like dark mode, light mode, I think is in there, and certainly all the landscape portrait things. Those are a lot of the things that we can set with those buttons that were down here at the bottom of our preview. But there's also a trait that you can do which is kind of like a view modifier, which is modifier. And you can create your own, it's not a view modifier, it's called a preview modifier. And I'm going to create one I'm going to call SwiftData Preview, or something like that. And this modifier that I'm going to create, it's going to take the entire preview and put the little container on there for it. So this is essentially what we're going to build. And just like when we make a view modifier, we usually create a little extension that makes it really nice, just a little dot something. We're going to do the same thing here, such that I'm going to eventually have this just say SwiftData. And if I say preview trait SwiftData, it means I get a container that contains my code breaker things around there. So let's go make this work right here so we can have this trait, which is this modifier. So let's go up here, File, New File from Template. This is definitely not a SwiftUI view. It's a preview modifier. And I'm going to call it SwiftData Preview. And it's definitely part of the UI. Previews are all UI, so we're going to put it in our UI place. Here it is. Got to import SwiftUI because it's a UI thing. And here we go. I'm going to create a struct. It's called SwiftData Preview. Okay, got that from the file name there. But it's not a preview provider. It's a preview modifier. So this already is starting to look very much like a view modifier. Because what do we want to do? We want to modify our preview so that it has this container, this model container. And the protocol here, preview modifier, is very similar to the view modifier one. It's got a func body that has the content that you're going to modify. That's going to be the view that draws the whole preview. But it also has this extra little argument here called context. And this is something that you can make a shared context that's used by this preview that you're building in there. And this can be any type you want. It's a don't care. And the one I want is, I want it to be a model container. The model container I'm going to use to wrap my thing in. So I'm just going to say model container. That's the type of a model container. And of course, if I'm going to do that, I better say import SwiftData, because that's part of SwiftData. And this thing returns some view. So you can see it really, really feels a lot like doing a view modifier, but it's not. We're modifying a preview here, which a preview is a view, of course. It's showing you a view, but this is more than just a view modifier. Now, inside here, all I'm going to do is take that content, which is the preview's content, and I'm going to do model container. And I'm going to pass that context that was passed to me, this context, model container right here. Now, don't confuse this context with that model context. Remember that @environment model context I showed you in the slides? That's a different thing. That's a context for the database that we pull out of the container. This context is just the context for your preview. This context has to do with creating preview context. It could be anything. It doesn't have to be SwiftData stuff here. It could be any kind of context. But who creates this context for me? This model container. Someone's got to create it for me so I can apply it. And the answer is, I do it with a static func. So I'm going to have a static func here. It's called makeSharedContext. And it's interesting. It's an asynchronous function. It also throws. And it returns this type, whatever this type is. It's a don't care, but it has to match that, of course. And it's going to make this model container for me. And the preview engine is going to call this makeSharedContext to get this model container, and then whenever it's putting together a preview, it's going to build its body by doing this guy right here. So how do we create this? Normally we would say something like let container equal model container for codebreaker.self. This is similar to what we saw with the little view modifier we had. The interesting thing here is that creating a model container can fail. Your disk might be full, or again, some kind of database error or something like that. So we have to try here. Now, why is that not complaining? Because where's our do catch? We have no do catch. Can anyone tell me why this is not complaining about do catch?
Because it throws.
Yes, because I'm in a function that throws. You see? And if I do a try in a function that throws, when it throws the error, it'll just throw it out of my function. And my function will exit. So we're allowed to do try without do catch if we're in a function that throws. So I have this container, and I can just return this container. This is the one I'm building. But I'm going to do one more other thing about this container. It has another argument. You can provide some configurations. And I'm going to provide just one configuration here, a model configuration, just another struct inside SwiftData. And the one I'm going to do is stored in memory only true. And this kind of configuration of a model says, don't go make a thing on disk for this, just store it in memory. Perfect for a preview. When I'm doing previews, they're quickly rebuilding all the time. We don't want to be storing that stuff on disk. So this just makes a little in-memory version of this thing. Now, one other thing I could do is in here, I could, say, maybe load up some sample data or something into the context that's inside this container. And the context inside that container is called main context. So that @environment model context thing is the container's main context. Containers have a var called main context, which is their main context. So I could use that context to load up some sample data here if I wanted. Now, in my app, I load my sample data over in that game list thing because I want my users to have the sample data. But if I just had some sample data that I only wanted to use in my previews, and maybe I don't give my user any sample data like that, then I could put it in here. This is cool, and this would work, as I was talking about before, if I said preview traits : dot modifier, one of these things, one of these SwiftData previews. But we want to have a nice extension like we extend view. But here we're not extending view, we're actually extending something called preview trait instead of view, because that's what that trait : argument is in preview. And it actually has a don't care, and in our case that don't care is view trait, because that's what we're doing. We are creating some traits that are going to be applied to the view that's built for it. And I'm just going to create a little static var here, just again like I might do in a view situation, called SwiftData, because I wanted that thing to be called SwiftData. And its type is going to be preview trait of preview.view traits. This is probably where some of you are kind of like, well, you're losing me here with all this. But I mean, I'm just creating a nice little static var to make this all easily shareable. And this thing is going to be equal to that modifier thing I said. Dot modifier, create one of my preview modifiers. And this is almost right, but I'm going to make two changes to this. One is, notice that this type of this thing is exactly the same as this. So what's a word I could use here? Yeah, capital S, self. So that means the type I'm in. And I'm going to do one other thing here, which is I'm going to say @main actor. Now, I haven't had a chance to talk to you about asynchronous programming. I'm hopefully going to get to it next week. But you can see that this thing has asynchrony involved in it. And that means that when this preview is putting all this stuff together, it's doing some of it in a separate thread. Everybody knows what multi-threading is, right? You can be doing things simultaneously, executing. And so this is clearly doing something there, asynchronous, but I don't want it to do that for this SwiftData thing. I want it back on what we call the main actor. That's where the entire UI runs. And it's all run synchronous, not multi-threaded, on the UI side. We only use the multiple threaded things for like loading data in the background or whatever this thing is doing in the background. But I want to be on the main actor. So I'm putting @main actor there just to be safe, because I see this async and I don't want to end up being on the wrong thread when I'm getting the SwiftData thing. Now, you can open your eyes and uncover your ears if you didn't want to hear about it. Bottom line is, take all this code, put it in your app, and the only thing you'll have to change is this. Because your @ model might not be called Codebreaker. It might be called something else, okay, Word something or whatever. And then you can just use this. And once you do that, then in all your previews, you can do this. A little hashtag or # preview, traits.swiftdata. And that will wrap your entire preview in a model container. And watch this. Whew, it's working. Okay, we can do this. We can even play it. Now, again, we're not putting anything in the database yet, we're just creating these things. But even just creating them requires the schema to be set up and all that, so we still need the container so we know what's going on. And then we can do this # preview trace thing everywhere that we have to do it. So let's see, code view has no preview, elapsed time, no preview. Game chooser, it definitely wants this. Game chooser is doing a ton of SwiftData stuff, and see it crashed. Game editor also needs it. Go here, paste. Game list, for sure. Game list is using a lot of this stuff. Paste. Game summary, yeah, I see game summary using Codebreaker right there. Paste. Match markers, no. The choice of chooser, no, no, no. See, it's kind of nice that we made all of these little helper views not take a game. And they don't even need that preview thing. They're all independent of that. So doing that little trick makes it so now we can be back to doing things like this and seeing our chooser working in our preview. And it's just using a little in-memory SQL database for us while it does all that. Kind of wacky, I know, but we have to kind of do it so we can have this working. All right, now let's get on to the main event here, which is that we want to start putting things in the database and querying things in the database so that they stay permanent, and also so that we can search on them and sort by things and all that stuff that we get with a database. Now let's go fix our code so that it, instead of just making our code breakers, it pulls them out of the database. And we're going to do that right here. You see this @state var games. Currently, we are the owner of the list of games. This is the source of truth for the list of games. Does everyone agree this @state is a source of truth for the list of games? We're going to change the source of truth right here to be the database. The database is now going to be the source of truth. No longer am I, this view, going to own the source of truth. The database owns it. So I'm going to take this out of data owned by me, and I'm actually going to put it up here in data shared with me, because it's essentially being shared with me from the database. And it's not going to be an @state anymore. It's going to be an @query, like we saw in the slides. And of course, I can't set it equal to anything because it's getting the information from the database. And it's a one-way trip from the database. It's only showing me what's in the database. And of course, I have to say import SwiftData. Anytime I use @model or @query or model context or any of those things, I need it. And that just worked. Look at that. It just worked. Now, I can enhance this @query, though, to specify which things in the database I want by, for example, putting filter, some predicate, and it's game in, game, name, contains, or whatever, to filter down the things I want. But I'm actually getting all of them. I want to get all of the games right now, so I'm going to have no filter. But I can also do sorting, because I want these games to come back in some order, because otherwise they'd come back in random order. When we do queries, they'd be in random order. So here in the fetch descriptor we saw on the slides, I had to do an array with sort descriptor. Remember that of Codebreaker? We don't have to do that here. Here we can just say \name, except that we don't really have quite enough information here to infer what @model that var is on. So we actually have to say Codebreaker.name. That's the full name of that var. Includes the name of its class in that case. By putting this sort Codebreaker name, we're just saying, yeah, go get all the games, since I'm not filtering from the database, and put them in this array and sort it alphabetically by their name. And I'm also going to have the order be forward, alphabetically forward. So games start with A first, all the way down to games that start with Z in the end. This is pretty cool that we can do this query and we can set it up the way we want. And now this games is always going to be, at all times, what's in the database that matches that. Even if other views are inserting things in the database or deleting things or whatever, this array is just going to constantly be updating. Even if someone changes the name of a code breaker in the database, this will change if we had a name filter or whatever. It's just like a standing query. It's just always going to do that. But there's one interesting thing about it, which is it's read-only, because the source of truth is now in the database. So I can't write to this array. I have to put things in the database if I want to write to this array, essentially. And that's why I've got all these red errors down here. Cannot use mutating member. I'm trying to remove from the list of games. Or here I'm appending to the list of games. I can't do that. That list of games is read-only. and showing me what's in the database at all times. But it's really easy to fix all these things because instead of interacting with the games array, we're going to interact with the database. We're going to go to the database to do these deletes and inserts. And how do we do that? Well, we know how to do that. We're going to have a mark here, data in, @environment, \model context, var model context. And this model context right here is our handle on the database. Let's go ahead and take a look at it in the documentation. Here it is. You can go down, see what kind of functions it has. Here's fetch. We talked about that with that fetch descriptor. And see how this thing throws? That look familiar to you? That's why we have to do try when we do a fetch. But how about insert? Here's insert. Doesn't throw, so we don't have to do any tries around that. Here you can find out if it has any changes since the last time it was saved. Here's delete for deleting objects. Here you can enable your autosave or not. Here you can explicitly save. Let's say you put some really important stuff in the database and you want to make sure it's saved right away. You don't want to wait for an autosave to happen. You can call save, but do notice that it throws. So you'd have to do a do catch around it if you do explicit saves. But it's not bad to do explicit saves like this. There's also an undo manager down here, which is really cool. You can do undo and redo and roll back to previous versions. We are only just skimming along the surface of what SwiftData can do here. We're just talking the basics. I'm just trying to get you started. When you get into it, you're going to see it does a lot of cool stuff. Even down here, this will save and did save notifications. You can find out when the autosave is happening, like right before and right after. And next week, I'll actually show you how we could use that to make our elapsed time work better. Because our elapsed time has a little bit of a problem. When we autosave, we don't autosave the elapsed time, because we only calculate the elapsed time on a disappear or something like that. We got a little bit of work to do there, and we'll use these notifications right here to do that. All right, everybody kind of get a feel for what model context is all about? It's the hub. It's our handle on the database. So let's go down and fix all of these games.remove, games.insert to do the stuff in the database. So here, this is swipe to delete, this on delete right here. So I'm just going to say for offset in these offsets, I'm going to ask the database, model context, to delete the game at that offset. And I don't need this anymore. Simple as could be. Now, by the way, sometimes you might be worried, I'm deleting maybe multiple offsets, although not here because really we're doing swipe to delete, so it's only going to be one thing. But if it were multiple offsets, you might be worried, oh no, what if I'm deleting early things in the array and now the offsets don't work anymore? One thing to think about with this games is that when you do something in the database like delete, it doesn't immediately update games. It updates games the next UI pass. The next time SwiftUI updates all the var bodies and stuff, it's updating it then. So it's not instantly changing it here. It's marking it for deletions in the database, essentially. It is actually deleting it, but then it's going to come around again, and that @ query will do the right thing. Now, what about on move right here? That's where we can press this edit button, we get the little handles, and we can move it. That makes no sense anymore, because we sort by name. Look at this query, sort by codebreaker name. So it doesn't make sense to pick things up. It's alphabetically sorted. So I'm just going to get rid of this on move. And if you wanted to have sorting, by user intervention, you'd have to have something in your model that kept track of some kind of priority or something like that that shows what the order of them is. What about down here? This is our game editor. And here we have edited an existing game, and here we have a new game. And actually, this is a bug right here. Somehow, nobody caught this bug, but that should be copy of game to edit. If you're editing a new game, we make a copy of that as well. And so the game editor edits the copy, so that should be copy of game to edit. But anyway, here I'm replacing the game that was there before by looking it up, getting its index, and replacing it. But in the new world, all I got to do is delete the old one and insert the new one. Simple as that. So I'm just going to go here and say model context dot delete the game to edit. That was the old one. And then I'm going to say model context dot insert the copy of the game to edit. That's the one we edited, right? Our game editor edits a copy. And then I don't need that. And then how about here? If it's a new one, I don't need to delete the old one because it's a new game. I just need to do this insert right here. And now I'm looking at this if, and I'm seeing two things. One is I get the index of the thing, but I actually don't need the index anymore. Because when I say delete, it just finds it and deletes it. So I just want to check to make sure it actually is an existing game. So I'm going to say if games.contains this game to edit, which it might not be because it might be a new game that was created, then do this. And then the other thing I'm noticing is that I do this insert here and in the else. So we can just put that on the outside and not even have an else there. Whether we edited a new game or an existing game, we're putting that thing in there. So this is actually kind of nicer looking code. Makes a little more sense even. Here's removing with the delete button. So this is press and hold the context menu or right click on the Mac. And this is totally trivial here. Model context.delete that game. And what about here? We're appending these games. Well, that's just model context.insert instead of games.append. Paste. And this is an interesting line of code. This line of code actually is going to crash our app. You see our preview is crashing right there. Why is that crashing? Well, because this is selecting a random game between 0 and the maximum count. So at worst, it tries to select game at index 0. And that is going to fail because games is still empty at this point. As I said, when I do those inserts, it inserts it in there, but the games array doesn't get updated until the next time around the SwiftUI updating thing. So games doesn't get instantly updated right after I do this insert. Now games has 3 items in it. It still has no items in it. So we have to get rid of this entirely. Now, what if we did want to select one here? Let's say we wanted to select this one, assign this to the selection, and then say model context, insert it. Because remember, we're talking about by reference here, so the selection would just be a reference to that code breaker name, and then I'd insert that thing in there, and then when the games came back around, it would all match up. But we're not going to do that there, mostly because we're going to be doing a lot of stuff here with sorting, and I want in our preview over here when we run it to come up in this mode, because this is where I'm going to be doing my sorting and searching. I don't want to be picking one and sliding over, so I'm always having to hit back, so just for my own convenience. But look, it's working. I changed that so that it's doing this. And now, let's go find out if this is actually working in terms of making it store forever. So I'm going to hit play, go over, and see if it's going to remember our changes. So here we go. Here's our sample games. I'll add a game here, untitled. Let's just go back and see if it remembers. So I'm going to go back here, hit stop, kill my app, and hit play again. And hopefully when we go back, we'll see untitled, and we don't. Why is there no untitled there? I thought we put those things in the database. It should be writing them to disk. Anyone want to guess why that didn't happen? Yeah? You never saved it? Yeah, exactly. We never saved it. We put the stuff in the database. We never saved the database. And again, we rely on autosave to do that. So how can I make autosave happen here? Especially when I'm working in Xcode where I'm going back and forth and killing the thing all the time. Real easy way to do autosave. Watch this. I'm going to do plus again. We'll make this untitled one. And I'm going to pretend I'm going to switch to another app. Okay, even just bringing up the app switcher, you don't actually even have to go to another app. Just bringing up this switcher, that's going to cause an autosave. Understandably, right? It's like your app is going in the background. You better save before it goes in the background. So now if I go over here and stop, and then run again, now we see our entitled stays. Yeah? So the question, I'm going to modify your question and say, well, how would I clear out the database? Let's say I've made a lot of games here, and I'm like, oh, I want to clear it out. Or a really important question is, what if I want to change the schema of my database, especially in an incompatible way, like a change of type or something? How do I just clear that database the heck out of there? You really want to stop your app, go back here, and see, here's my code breaker. You're going to press and hold until it says this, and then you're going to say remove app. And when you do remove app, it's going to say, do you really want to remove this? And I'm saying yes. And now it's going to say, deleting this app will also delete its data. See that? That means your SQL database. It's going to get deleted. So I hit delete. It's gone. Now when I go back here and run again, you're going to see that that untitled thing I created, not going to be there. See? I'm back to sample data. So that's a good thing to know, that press and hold delete to get rid of your SQL data. And anytime you make a change to your schema and maybe your app crashes on launch, hey, give that a try of deleting out your whole data just to see if that's the problem, some incompatible schema problem there. And it's not just storing, by the way, the games, it's storing the moves too. Look, here I'm going to make a move to this mastermind right here, and then I'm going to make it autosave. Then I'm going to go back here, I'm going to stop, run again. And look, one attempt. There it is. It didn't forget. So it's remembering everything about my model. Yeah.
What was the motivation for forcing the autosave?
Okay, so the question is, why am I forcing this autosave? Why am I doing that? The answer is because I'm in development and I'm switching back and forth and killing my app all the time. A real user, they don't kill their app. Exactly. It'll be sitting in the background, and they'll bring it forward and it'll sit in the background. People rarely, although some people like to do this more than others, but people rarely go through and just like kill all my apps. Some people do. And of course, if you restarted your phone, that would kill your app as well. But most people just switch to another app, and then the other ones are all sitting there in the background. But when we're doing development, we're always hitting this stop button right here. That kills it. And if we have an autosave, we lose our changes. That's a good question. Now, while I'm in here, let's go ahead and take a little detour and do model context.fetch. We don't actually need to do model context.fetch because we have this @ query up here at the top, and it's querying all the things we need. It's really great. And we actually even use it down here in this add sample games because we say if games is empty. That's looking at that @ query to see if there's anything in the database. But what if we didn't want to do this games is empty and we wanted to query the database directly ourselves? We don't want to use the @ query. We want to look in the database, make our own query. And let's look what it looks like to do that. And you all remember from the slides, I hope, let fetch descriptor, this is the key of doing a query here, equal fetch descriptor. And remember that we specify which things we want to fetch with the don't care of this, which is code breaker in this case. So we have some arguments here. One of them is the predicate, remember? It's got this predicate thing. And the predicate takes a closure where for each game in the table, it's going to ask you to give a true or false expression. So I'm going to return true. That means fetch everything. Because this little closure right here is always going to return true, which means it's going to go through every single code breaker in that table in the database, and it's going to say, keep this one, true. Keep this one, true. Keep this one, true. So it's going to fetch them all. Now, of course, often we wouldn't return true here. We do things like game.names contains foo or some little expression here that decides whether we want these. But in this case, I'm trying to decide if the database is empty, so I'm going to fetch them all and see if there's 0 of them. Now, this is such a common predicate to have, all of them, that there is a static for it, predicate.true. And of course, we know this is a predicate, so we can type infer. So we would often say here, predicate.true. Now, what was the other argument to a fetch descriptor? The sort by. And this is an array of sort descriptor. And this also is got the don't care here. And we can give it the name. Now, in this case, I don't have to say /codebreaker because, of course, this knows that it's a sort descriptor for code breakers. And I'm going to show you that little weird syntax we saw on the slides, that it's legal to do this. No one ever does this, of course, but this is the same thing. There's kind of an implicit .init when you create something like that. And why this is good is that we can now infer that. And that's why we're able to see that init /name. I know it looks weird, but that's why we do it. Especially if we had multiple things here. We don't want it to be a mile long and have a whole bunch of sort descriptor code breakers in there. Just be redundant. Now, interestingly, here I'm just fetching things to count them up, so I don't care how they're sorted. You can come back in any order you want. I'm just trying to see if there's 0 of them. And you know what else? Predicate true is the default. So I don't even need that. So I can actually just say fetch descriptor, open parentheses, close parentheses. And that is a fetch descriptor that fetches everything in random order. So now I'm going to use this fetch descriptor to fetch everything in random order by saying let results equal model context dot fetch that fetch descriptor. And this is going to give me back an array of code breakers. But it doesn't work because call can throw, but it's not marked with try. Okay, no problem. Try. And now I'm going to get another error here. Errors thrown from here are not handled. That means you're not doing do catch around it. So let's put a do catch. Do this thing right here and catch. And I can say let error, or I could say let foo if I wanted the variable to be called foo inside here, or nothing, in which case it'll default to being called error. And now I could say something like had a problem counting games :/ error or something like this. And this error is the error that got thrown to me. And all errors have something called localized description, which is a nice localized description that you can sometimes put that in front of a user because it is localized to their local language. Localized means it's in their local language. But sometimes it's a very technical error. You wouldn't do that. You just would be looking at the error and deciding what to do yourself. And if this doesn't fail, though, then I want to do this down here. So I'm going to cut this, put this up in here. And instead of games is empty, I'm going to say results.count equals 0. So that's the same thing, but just looking at the stuff I got back from the database here. Everybody clear with this? Now, if this fails, it immediately jumps here. And after it does this a print, it then jumps down here. If this doesn't fail, then it just goes to here and starts executing these things. Now, we actually don't need a do catch at all. In fact, if we just say try exclamation point, then we can get rid of the do catch. And then what will happen here is if this fetch fails because of a database error or something, it's just going to crash my program. It will not continue to the next line because my program will stop because it crashes. Notice that this result, I told you, was an array of code breaker. I just option clicked on it. Do we all agree it's an array of code breaker? I'm going to change this try now to be try question mark. And now I'm going to option click on results. And look what type it is. Array of code breaker question mark. In other words, optional array of code breaker. And that's why this line of code doesn't work anymore, because it's using the var count on results. Results is an optional. Optional doesn't have a var called count. So I need to do something here like let results, comma, results.count equals that. Everyone see why that would work? Here I'm unwrapping this. And this is the right logic, too, because honestly, if this fails, I don't want to try to do this. Probably my database is corrupted or something, so I'm not going to try that. So this is great, because if this results is nil, then this is not going to be successful. It'll never get anywhere near here. There's actually another way we could do this here, which is chaining, optional chaining. We could do this. Results question mark.count. Remember, if you put a question mark after an optional in a dot thing, where it's this, dot, that, if that thing is nil, the whole expression is nil. So if I have this and results is nil, then that whole blue rectangle there is nil. And nil is never equal to 0. Nil is never equal to 0, so that will always fail. So this is another way we would probably think about writing this. We also could have done if let that, and then said results.count equals 0. That's another way we could have done this here. All right, so I'm going to do one other thing here, which is, look, I'm fetching every single game in the database just to see if there's any in there. This is a little bit using a sledgehammer to find out if the database is empty. But there's another cool version of fetch called fetch count. Fetch count doesn't fetch them all over. It just counts how many match the predicate and tells you how many it is. So that turns results right here. Instead of being an array of code breaker, it's now an int. So I don't need to say results.count equals 0. I can just say results equals 0. Now, even in the fetch case, yeah, it's fetching all the games, but it actually doesn't bring all that data over from the database. It kind of makes little skeletons of all the things, and then when you start accessing the vars, then it's going to fault in the data. So it's very efficient, even if you're fetching huge numbers of things. It's not actually pulling over tons of games and all their attempts and all that stuff until you start looking at the attempts. Then it's going to start pulling them in. So it's efficient. But fetch count avoids even doing that, because it's doing a SQL operation that returns an int, and that int is coming back from the database to you, which is how many things there are. So that was just a little detour I did there to show you how to use model context to do fetches, but we rarely do this. We're usually going to rely on something like this @ query up here to get the data out of the database that we need. Let's go back and run this. We're going to try and play the game a little more. So let's take our mastermind right here. We've got this random guess here. I'm going to make 4 guesses in a row. One is each color. So there's red, there's blue, there's green, and there's yellow. It looks like my game is working. But watch, I'm going to autosave. Swipe up here so that it forces this thing to save. And then bring it back. And now my attempts are in a different order. Look, this is not red, blue, green, yellow. It's red, yellow, blue, green. So, and this was my first guess. It's not at the bottom. It's now at the top. So it totally changed my game in a way that's just like, this isn't even Codebreaker anymore. This is that problem I was telling you where we have an array. Let's look at the array over here. It's in our model, Codebreaker. We have an array right here, which is our attempts. And that array is an array of codes. Codes are @ models. They have their own table in the database. We've got code breakers in one table. We've got codes in another table. So this is always going to come back random ordered attempts. And that is absolutely no good for us. Completely breaks our game. So how are we going to make that thing be in order? Well, this turns out to be very easy for us to fix. I'm just going to timestamp every attempt. Every time you create a code, it's going to timestamp it. And then I'm going to sort my attempts by the timestamp. Let's go over here to code, my model. And here it is. I'm just going to add a let timestamp. Actually, it's got to be a var. Things in models have to be vars. That can't be a let. Because it's going to be creating this code and sucking the data from the database and jamming it in here, so it can't be a let. We're going to have our timestamp here, and it's a date, date.now, in fact. Right? That timestamp is just now. Whenever I create the code, wham, I'm going to timestamp its creation. So now I know the instant every single code was created. So when I make an attempt, that's going to create a code. I know when it was created. Now back over in my code breaker, I need to take this attempts and sort it. But just like with all the other things we're doing, I don't want to break all the rest of my code. I got a whole bunch of UI that is asking for those attempts. It's for eaching over them. It's printing them out. I've got code that's checking to see if the game is over by looking at the most recent attempt to see if it matches the master code. You see what I mean? I'm going to break all that if I have to intervene here. So instead, I'm going to make this be underbar attempts, just like I did with underbar kind. And I'm going to use a var attempts array of code, which is a get and set computed property. And the get is going to sort it, and the set doesn't need to do anything because if it's a random order, you can set it in any order you want. But the get is always going to sort it. So let's have the get sorted. Get is going to get my underbar attempts array, but it's going to sort it. And hopefully all of you learned how to do sorting because I put it in one of the assignment things. But collections have a lot of sorting methods. I like the one where you give it a closure, and I'm going to have $0.timestamp is greater than the $1 timestamp. So this version of sorted, you give it a closure, and it returns whether one thing is less than the other. It's a true, false, whether it's less than. And if it knows out about every single pair of things, it can go through there and sort it. And then on the setting side, I just say underbar attempts equals the new value. You can give me the attempts in any order, because I'm always going to sort them on the way back out. And this is all we need to do. This is solving our problem. So let's go over here and see. Let's run it. Make sure it's not breaking anything. This is going to be something interesting happening here. Look what happened when I ran. All my attempts for the mastermind are gone. Why did that happen? It's because I changed my schema. I added a new var to my schema, so when it came in here to load this model, it couldn't load that model. So what I'm seeing here is the sample again being loaded. Yeah. What do I mean by the word schema? The schema is the description of the types of all the variables in the database. And it also includes what types there are. So a database is made up of tables. Imagine a big spreadsheet. And it's got the columns across the top, and those are all var types, strings, ints, whatever. And then the rows are the code breaker games. And then I've got another table which is codes, and it's got things across the top like kind and pegs, and then every code is a line in there. So that description of those tables and what the types are along the top, that's the schema, the database schema. And when I added var timestamped, I added a column to my spreadsheet. I changed my schema. You see, I changed it. So it couldn't load previous things out of there. And when you change your schema, I think I mentioned this, if you've already shipped your app and you change it, you can't just ignore all their data. You have to migrate your schema, get all the data out of the old schema into the new one. And there's tons of mechanism in SwiftData to do that. I'm not going to show it to you. We're stuck with the very lightweight kind of migration here, which is that it just throws stuff away or whatever. So let's go in here and make sure this is working. Red, red, red. And we'll go blue, blue, blue. We'll go green, green, green. We'll go yellow, yellow, yellow. And now I'm going to auto-save, and hopefully it's still in this order. Here we go. Auto-save. And back. Woo! Stayed in that order. Red, blue, green, yellow. Nice. That was a simple fix. Fix that order there. I'm going to go back to something like Game Chooser over here. Take a look at this. Maybe we'll even pin this thing right here. I have a database now. It's storing my games. Fantastic. I have persistence. Now let's take advantage of being persistent in a SQL database, in a searchable, sortable database, to do some sorting. So you see this list of games, Earth Tones, Mastermind, Undersea. Let's go through here and allow the user to sort this by something else rather than alphabetical. Do we agree this is alphabetical? E, Earth Tones, M, Mastermind, U, Undersea. It's definitely doing it alphabetical, forward alphabetical, which is what we said we wanted over in our game list, the @ query over there. I want to have some UI that lets me say, no, sort this by the most recently played game, so that I can just see the games that I played recently and get to them quickly. So how would we do such a thing? First of all, let me clean up a little bit here and close some of these things that we're not using. This and this and this, this and this. Keep that. We'll close this and this. All right, so we'll go back to our game list right here. And it's the thing that's doing the query. It's the thing that's going to do the sorting of the thing coming back. And right now it's sorting by name, but we need to be able to make this be sortable by something else. So I'm going to start by making a little enum, which I'm going to call my sort option, which lists all the ways I'm going to let the user sort this. So there's case name, which is the current sorting, and then recent, I'm going to call the second one, which sorts by recent. I'm just adding this enum in here, and I'm going to be adding more cases to this, but these are the two we're going to do to start. Sort in these two different ways. Now I'm going to go back to my game chooser over here, and I'm going to add some UI to choose one of those two things. And the UI I'm going to add is something called a picker. So you haven't seen this before. It is a great little piece of UI to pick between discrete values. It's really good for picking enums values. And I'm just going to put it right here on top of my game list. Picker is what it's called. And it has a label, like this is my sort by picker. This label, you're not going to see it unless you're in a form or something like that, right? You know how forms put the labels on the things, like when we had our color pickers in there, the label was shown. But here I don't have it in a form, so it's not actually going to show this particular thing. And then the next argument is the selection. So this is the thing that the picker is going to select. Well, what do we want our picker to select? I want to select one of those sort options. So I'm going to say $sort option, and then I'm going to go up here and say @state private var sort option, which is of type GameList.sort option, and we'll have it default to name, which is the default one. And then the next argument is something that makes a little view that is the view you click on to choose that option. So for each option in here, and how am I going to get all my options? Well, it's essentially my game list sort options, and I really want all cases of that. And if you remember from slides, There's a way to do this, which I'm going to show you in a second. And we need the ID. Well, it's an enum, so \self should work pretty good because each enum is a discrete value. It has to be unique, so that'll be good. And then it'll pass that option into me here. This is a for each. And I just got to make a little view. I'll just make a text. And in that text, I need to somehow show the option. For now, I'm going to say \option. So I'm going to let Swift convert that enum case to a string, and we'll put that in there. Okay, we can do better than that, but that's how we're going to do a start. And it's complaining about all cases. Does anyone remember how we can make this enum all cases work? Yeah, well, you can just say that it conforms to case iterable. And when you conform an enum to case iterable, it automatically adds a static var called all cases, which is all of your cases in a little collection. And that made it work. Let's zoom in a little and we can see it better. Plus, here's our little picker right here. See, it's at the top. And I can click on it, pick recent, click on it, click name. Yeah, pretty darn ugly, though. I don't think you would like this. If this was your app, you'd be pretty embarrassed by this. And there's a lot better looking pickers, and we're going to pick one of them. The one we're going to pick here is .pickerstyle.segmented. Woof, much, much nicer here. So picker style is a view modifier you can put on a picker to pick which style you want. And there's a few styles there, and some of them depend on your context. Like if you're in a form, in a navigation thing, then there's a nice picker that will actually let you navigate to do your picking. But segmented style is nice when you have 2 or 3, maybe 4 options like this. I don't really like that it's jamming it up against the edge, so maybe I would also add a little padding in the horizontal direction. So yes, padding can take things like horizontal and vertical. Now that actually looks pretty good, I think, right there. And look, kind of animates it for us. Now, I'm not super fan of lowercase n name and lowercase r recent, especially since our edit button is capitalized. We tend to capitalize words in our UI. So let's fix that. And instead of using whatever Swift gives, converts that enum to, let's give it a real name. So I'm going to go over here to my sort option. I'm going to add a var title, which is a string. I'm going to switch on myself. And I'm going to say, if it's name, how about sort by name? And in the case .recent, maybe I'll just say recent. Don't even need to say sort by recent. And there's 2 things about this that are important. One is, we're designing and picking the names that we want to appear in the UI. And there's a really important consideration about strings that appear in the UI that we have not talked about, but it's localizability. When you build your app, you want it to go worldwide. So you want this thing in French, and you want it in Russian, and you want it in Hebrew, and you want every language you want this thing to be in. And of course, sort by name is going to be in a different language everywhere. And putting a bar like this is a great place to put the localization here. There are functions like localizable, key value, and all that you can use to make these strings appear in a little table that a localizer goes through and edits. This title is what we want to use then in here instead of that. So let's go back here and use that title. Instead of doing option, I'm just going to say the options title. And look at that. Sort by name and recent. Looking pretty good. Now we got to make this recent and sort by name actually do something. So how are we going to do that? Well, I'm going to have my game list right here. Take another argument, which is sort by this sort option that I've collected right there. I'm going to be able to pass this into my game list. Now, you might be asking yourself, why did I put this picker here in Game Chooser? Why didn't I put this picker that picks the sort by over here in my game list? This is where the query is, so why wouldn't I pick the sort order over here? And the answer is, I can't put it here because the query is here. And this is what I was talking about in the slides, where the only way to customize your query, the sorting and predicate of your query, is in the init of a view. So I'm going to do that in this view's init. I'm going to have init. It's going to take that selection, which is a binding to a code breaker optional. And it's also now going to have another thing, which is the sort by, which is a sort option. And this, inside this init is where I'm going to set the sort by and predicate of this query so that it does the right thing. So you can see that I can't pick the sort option here in GameList because it would already have been initted. There's no way for it to call its own init and get that query updated. So you have to be able to decompose your views so that you're passing the sorting options or the searching options into that view. I have an init right here. We've got my binding to code breaker and the other thing. So the selection, if you all remember, this is going to be underbar selection equals the selection, right? Because if I have an @ binding, the underbar one is the actual binding struct. The non-underbar one is the thing the binding struct binds to. So I'm going to say underbar selection equals this binding. And I'm going to do the exact same thing for the query. The underbar version of games is a query struct. And this query struct, we can specify all these arguments. So I'm going to get rid of the arguments up here. And instead, down here, I'm going to switch on this sort by option. And if it's name, then I'm going to set my underbar games equal to a query struct. And this query struct is going to have the sorting that I want. So in this case, code breaker.name for the name, and case.recent is underbar games equals the query sorting by code breaker dot what? Last attempt date or something like that. I'm going to have to update my model to have some sort of last attempt so I can sort by it. Make sense? See what's happening there? So I'm setting up this query in my init, and this is the only way to have these arguments be variable. So let's go ahead and add this last attempt date to our model. Here's our model over here. Put it at the bottom, var last attempt date. And when we first start our game, it's got to be nil because we have not made an attempt, so it doesn't have a last attempt date. And then when we make an attempt, here's an attempt right here. I'm going to say my last attempt date equals now. And believe it or not, that is, I think, all we need to do. Right? We've made our game list update its query based on this sort by. We have our game chooser. It's passing the sort by that it picks with this picker. So let's see if it works. I have a problem here. What do we got? Missing argument. Oh, sorry, this is our preview down here. This wants an argument for the preview. Let's actually make it default. So we'll have this init have the sort option default to .name. And then our preview won't need that. Ready and recent. Oh, look, it put them in a different order. Now, it's putting them in random order here because all of my last attempt date things are nil. So when I say sort by name, sort by recent, it's just sorting them in random order. But let's go through here and, for example, have our earth tones have an attempt. Make our earth tones have an attempt here. And this should move it so that it is the first thing. Uh-oh, it moved it to the bottom. How about undersea? Let's make it have an attempt. Whoop. Oh, I guessed it. It moved it to the bottom. So it's working. It's doing it by recent, but it's putting the most recent one at the bottom. I don't want that. So let's go back here to our query, and instead of having it query it this way, we're going to do order.reverse. Also, I really don't like that this thing is not animated. See, when I switch between these just all instantly change. So that's easy to change as well. If you remember, when I have a binding, like sort option, I can attach an animation to it. So here we'll just do default animation, but we could do ease in, ease out, or whatever. So now when we change, woo, we get some animation. How about mastermind here? At the top. You know, I was thinking about this. I might want to have that last attempt start out not being nil and have it be the day I created it. Having that thing be nil means that sometimes the return value is kind of coming back randomly, and I don't really like that. So maybe over here in my code breaker, instead of having this date start out this way, I'll start it out as date.now. Let's do searching, because searching is going to require us to do the filter part of this query. I'm going to add another argument to my init here, which is name contains some search string, like this. And again, we'll have it default to this. And then over in my chooser right here, I want to have the game list say name contains. And I'm going to give it a search string, which is just going to be some @state of mine, private var search string is a string. We'll also have that start out as empty string. And I have this search string, which I'm going to pass into my game list and ask it to search for it. And it's going to search by name. Like I'll type mind, and it'll find mastermind. Or I type C, and it's going to find under C. That's what I want to do. You could imagine how we do this, right? Put a text field in there, text $. There's actually a really cool way to do this, which is just to put .searchable text $search. .searchable adds standard looking search UI to your UI in whatever way is most appropriate. And SwiftUI is really good at figuring this out. In this case, look, it added the little search field right up here under the title of this navigation thing here. And we can click in here and start typing, mind or whatever, and it is searching with that. And it's going to be recalling this over and over with the new search value. So all we have to do inside game list is use this search that was passed to us to filter this queries that we're doing. We're doing these queries here. We're going to need to add a filter to it. Now, a filter is what? What's the type of a filter? Remember? Filter, query filter, fetch descriptor filter. It's a predicate. That's what that hashtag predicate thing is. It's a filter. So I'm going to say let predicate equal predicate. And this one I'm going to have to say that it's a code breaker. There's nothing for it to infer of that. And this predicate takes a closure. And inside this closure, we're going to decide which ones we're going to include and which ones we're not. If my search string is empty, then I'm going to grab them all. Or if it's not empty, then I'm going to check to see if my game's name contains that search string. So you see how I'm using simple Swift-like language here to specify my predicate? And then I'm going to use this predicate in both of these queries. So filter by that predicate and filter by this predicate. Let's try it and see what happens over here. I'm going to try Earth. Woo, look at that. Master. Excellent. How about mind? Oh, it didn't find mastermind. Why do you think it didn't find mastermind? Anyone want to guess? Capital, yeah, capital M. My search text automatically capitalizing. Now, of course, I could go in and use the view modifier I showed you before to make it so that it doesn't auto-capitalize. Auto-capitalization is called. But I'm going to show you another way to do it, which is I'm going to have my little predicate search lowercase and search capitalized to see if it matches. And I can't really do that inside here. I can't call things like lowercase and all that stuff in here. Those are not supported functions. They're not in that list of things I told you could do. But I did say you could do constants. So I'm going to have lowercase search equal that search thing lowercased. And then I'm going to have capitalized search equals that search capitalized. And then inside here, I'm going to say the game contains the lowercase search or the game name contains the capitalized search. So let's go back over here. Try again. Mind. Ooh, it works. Earth. How about ER, which matches both mastermind and under C, or mastermind under C. It's cool. So your assignment in assignment 5 is to take your assignment 4, make it so that the games are always remembered, and also do, I think I make you do sorting and searching. Not sure. Might have. I can't remember exactly what I ended up putting in the write-up there, but probably. But you know how to do sorting and searching now, and you know how to make things persistent. Most of the work is converting your thing over to be an at-sign model. Once you do that, then it's really easy with that at-sign environment model context. Putting things in and out of the database is actually quite trivial. Okay, any questions? All right, that's it. I will see you in 1 week, right? 1 week from today, not on Monday.